Hello everybody, welcome to another stream. How are you doing? Hi there Paya, welcome. How are you doing? How are things? Good to see you. So, last stream, I had to cut it a bit short, but we made this feature work, right, which is the printf buffer, or the hprintf buffer, so we can print from shaders and we can see back something from a shader invocation in the terminal. Obviously, it's a bit crazy what's being printed out, and you would typically put an if statement to make it a bit easy to see what you're seeing. But yeah, here's an example of it actually working. Hey there, Rizuma. Welcome, welcome. How's things going? So, what we're working on today is continuing this thing known as a readback buffer. So we've got one readback buffer already, and that is reading back the printf data from the GPU, which we print out in the shader if we have any debug printing, right? We want to have two more types of readback buffers. One is going to be so we can read back a resource, a particular sub-region of a resource. Maybe you have a buffer that's this big and you want to grab this part of the buffer, pull it back to the CPU to use. And the other one is going to be like so the first one, which we just mentioned, is going to be purely controlled from the CPU side of things. But what happens if you want the GPU to send the CPU back and be in control of what it sends back? Well, what we need is essentially like a command buffer that instead of going from CPU to GPU, it goes from GPU to CPU, right? So that's the second type we'll be working on. So what I'm hoping to do is hope we'll get the first type of that done today, and maybe the second one, maybe some of the second one as well. All fine. I'm grinding the assets processor. Nice. What do you mean by? So you've got like a build step, and you're processing your assets into some runtime assets, right? Hey Perry, how's it going? Yeah, the wife is all good. So last time we ended stream early because she had some trouble breathing well. Like she could breathe, but it just wasn't well enough. So she had trouble sleeping. And she was a bit wheezy as well. But she's got some. We had to go to A&E, and we spent about 3 hours there. And then she got some. She got some tablets that she takes now, and she'll be taking those for 5 days, and hopefully, it should all clear up and go. Effectively, like the way I got it explained is she has hay fever, and basically the baby's like big enough now to the point where it's squishing the lungs, so it's like causing like basically the hay fever is not helping with her breathing, and obviously the baby's going to be doing that anyway. So the thing that needs to get fixed is the hay fever. So she's just hopefully that will be good. What about this command buffer from GPU? Yeah, so effectively, like, what we have, let's just see this example. We've already got one type of readback working, right? Hey there, Glorious. Hi there, Karaken. Thank you, thank you. All is good. Thank you, thank you. Oh, man, glad to. Above is good. Yeah, they're fine. Yeah, they're really great. I was shocked to see you not when I got back walking, but yeah, Yeah, no, yeah, it was. Yeah, yeah, it was a shame. And we waited there for like 3 hours. It was so long. But I'm glad it was 3 hours then and not 3 hours, you know, right as we're about to go to bed. You know. So it was worth it. Yeah. Um so effectively like for Like we have a way now in the code base. Let's just quickly show this. Right, in one of our shaders, we have a way to call this hprintf. It allows us to basically put in a string with some arguments and then put in like the arguments afterwards. And it'll copy that to a buffer on the GPU, and then we can read that back. This is effectively like a command buffer in a way that goes from GPU to CPU, because we pick it up on the CPU side and read every print command, right? And then we display that print command in the terminal. So that's what we're doing here. But this API here that we designed last stream is one for the CPU to say, hey, I want to read back this resource, and then 2 frames later it can actually read it back. But we might want the GPU to do more things than just print, like the GPU to issue commands for the CPU to do, like for more debugging things, or maybe there's some processing that goes on the GPU, and it might want to tell the CPU the result of that. And so rather than this and the CPU request from the GPU, what is that result going to be? Instead, the GPU will be the one that makes the decision for the CPU to act on this data it's about to give it. So it could be used for many things like debugging, but also maybe there's something that the GPU generates and it wants to issue the CPU to go and do something. So yeah, just having a general system in for that would be a good idea. So we're just going to work on that today. Well, that hopefully we get to that today. We're working on this CPU version today. Or the CPU to request the GPU to give it back some data. That's always good. Thank you. Yeah, send it any. Right, so this one, read back data from a resource by copying the resource to temporary lived buffer on the GPU. When the CPU requests a read back, it will get its chance to read back the data 2 frames after, while preparing a new frame. Okay. To read back the data 2 frames after when preparing a new frame by calling GPU readback data. Use this API when you want to control how the data is copied from a temporary lived readback buffer to a longer lifetime allocation. Excellent. And this one is basically going to do the copy for you. It will do it within that window. So this is built on top of the other resource readback API. So we'll just do this, which does a straight copy from the temporary library of your choice. And lets you know when it's done. Excellent. See, we could do a readback ID, or we could do a fence, I reckon. It depends. No, you might not readback ID. So yeah, so this one down here wants like some form of just a notification to say that it's done. Yeah, I think this will be fun. No worries, no worries. All right, so let's get this top one implemented first. GPU. Hey, they're not so red. Yeah, doing good, doing good. Oh, I'm not sure if everyone's well, if you guys have been in the Discord, you'll know. But yeah, I recently got a promotion, so I'm no longer a junior anymore at work, which is super cool. So I'm now just engine programmer, basically. Yeah. So yeah, that's super sweet. Thank you, appreciate it. Yeah, so I'm glad that's all been recognized now. Um, yeah, it's pretty good news. Right in time for the baby as well. You know. Yeah. It's good though because while I was a junior, this is like the first job where I've been a junior, and you don't get treated like a junior, you know. So that's good. You know. But at some jobs, and then it's basically like a real pain to be a junior and just exist in the working environment. You know what I mean? Yeah. Back when I was junior, yeah, there's only like it's only like 4 days ago. Yeah. I went back in a junior role because one, I was desperate for a job. Two, I was changing position areas in programming. Um, so yeah, but it's all worked out, so it's great. I've been there 2 years now. Yeah, should I make them use HCC now? Yeah, maybe not. Yeah, we're more of a C++ code base, so it won't be. Yeah. Um. Hmm. So let's go hop into the internals and have a little gander. Wait, there's a faster way. No, there isn't. Wait, is there? There must be a way where I can say open it in a new tab. Open it in a new tab. Yeah, I don't know how to use it. Right, I'm just going to do tab new, and then do that, and then go. Excellent, we're in. C++. Is it? Yeah. Yeah, you can get really complicated C++, you know. But what's nice about work is we don't go too far into that, which is good. It tends to be quite C-like, so it's quite easily readable and manageable. You know, things can get really implicit with C++. Like, stuff just happens, and you have to be aware of all these constructs with how the language works. Um, yeah. Okay, so we need something like this. So the upload buffer has a cursor, it has a bunch of entries, right? We basically need this, but for readback. But instead of allocating something and then writing into it, we allocate something and something will be written into it from the GPU instead, right? So, you know, it just works the other way around. Um, I don't know. You know what? It's the same. It's the same structure. You know. So called like host copy or something. You know. So like host copy, and rather than having source offset, you'll have CPU offset. Rather than DST, you call it GPU res ID, GPU offset, right? Um, so obviously we'll sort that out. Oh. Host copy. Right, let's see, we changed the name. No worries. Rightio. Also, hey there very much, how you doing? Oh, you can overload the operator of, the implicit casting. Yeah, you can overload all the things. And the implicit casting can be defined either in the the type that you're going to or the type you're going from. It's all sorts of goodness. Is having a bunch of stuff you want to pipe in and out a good reason to bundle the thing into a strict? Oh, strut. Is it good? Is having a bunch of stuff you want to pipe in and out a good reason to bundle things into a structure? I'm still struggling to compress my code sometimes. Yeah, structures are generally good when you want to just group stuff together. Here I could have put it into these into a structure, but I'm not passing this thing around as a unit of things separately or anything like this. So until I do that, it's not much worth doing it. But yeah, typically you put stuff in structures if you're passing a group of things around, but this is all accessible from a global variable anyway, or if you want to have multiple instances of that thing, right? But yeah, typically like another good place for a structure as well is just to put things all next to each other. So when you have a global, there's only one global, right? Rather than having like 27 globals, you know? So stuff like that. I don't know. The question was a bit general, so I hope I answered it and it sort of gave you some ideas. Doing good, had a terrible workspace or workplace situation. So yeah, just Googling Rust jobs in my area. Okay. Yeah. Yeah, that sucks. So I hope you can get that sorted out. Um yeah, it's not good when, it's your day-to-day thing, is it? Um yeah, I'm sure there's maybe some Rust jobs online maybe that you could do remotely. So definitely take a look at a remote as well. Um oh, right. So the idea is like the upload. What we want to do is, so I think we can just take the upload one and just like change the problem around, So if the size is 0, well, we need like a null ID. Can we sort that out somehow? Right, core ID define. Oh, there's a null. Yeah, but then I have to wrap it in the thing. Null raw, null name. So it's just having a distinct type, Nothing, nothing too crazy. GPU readback ID. Oh yeah. So the idea is if the frame has not started, readback must come before frame start. No. Must come after frame start and before GPU frame submit. Right? So it has to be called within that certain window there. Is that right? No. Everything. Yeah, but why does upload have to wait until... Must come before GPU frame start. No, because I think we put it in the submit, right? Let's Vulkan. Right, so in here, frame submit. I think we do all of our upload stuff in here, right? Or did we do it in frame start? Couldn't have done. Flash the caches for the upload buffer. Oh, sorry. Yeah, I was getting confused. Because we're recording it directly into the command buffer. Like, the way our system works is it's not deferred. We don't defer it into a temporary array somewhere, then record it into a command buffer later. We record it straight into the command buffer. Right, that's fine. Yeah, we change that in future if we really feel like we need it. Right, that was good to remember. Okay. So this one has to be... So if you're saying, hey, I want to read this back, you're injecting it. So it is true. You want it to be in between frame start and submit, because you might have... Because what you can do is you can... Like... Right, this is... So you might have GPU dispatch, and you dispatch... Oh, we need to put the word command before here, I reckon, then. But yeah. So you might say, I'm doing a dispatch, and you change some texture. Then afterwards, you read back that texture into the readback buffer, right? And then after here, you mutate the same texture. But you got the version of it in between those two calls, right? So you can choose exactly when in the frame you want to actually do the readback, which is pretty nice, right? So that's pretty cool if we design it that way. So yeah, which means the name has to slightly change. So these would be... Let's say you got many passes on a thing. Maybe you want to make it clear that what you're referring to long to... I'm sure if we get the question. Let's say you've got many passes on a thing. Maybe you want to make it clear what you're referring to along the way down the pass. Maybe you don't even pass the thing into... Yeah, I guess it could be a good idea. It could be a good idea to do that, Rizuma. I think just grouping data together is fine if you put it in a structure, right? But yeah, I guess just make sure you're not doing it too much, you know, because everything can have an extreme, which is not good. Vulkan released a new official example code today on how to properly create swap chain and stuff when resizing a window. Something along the lines of this. Right, I'll look at that in a sec. Not implying that you don't know that already. Just curious official way. Yeah, so it's really weird. I actually didn't... I thought you'd had to create it by just calling VK create swap chain, it recreates it, right? But turns out you have to destroy it. And then create it afterwards, because on X11 it's got some dodgy behavior, I think, and it's in the Vulkan cube sample that someone pointed me to before. It's really weird, and I'd like to see what they suggest. Yeah. So this would be good to have a look at. But yeah, thanks. I'll take a look at this. Should we look now? So C++, this will take me ages to look at. Recreate swap chain. But yeah. Anyway, I'll look at it later. Thank you, though. I really appreciate it. What responsibilities do seniors have that juniors don't? Well, I'm not a senior. I'm not a junior. I'm just mid-level now. Do I do graphics stuff professionally? That is correct. I do graphics things. I do the graphics things. Right, I need to correct those. GPU. Alright, just give that a nice little correct. Oh, no. Rightio. That was a good little discovery that we did, so I'm glad that we thought about that design. Yeah, I'm an engine developer. But yeah, I do graphics though. I'm technically on the graphics team at work, but the official title is engine developer or engine programmer. Since I live in RAII town, they usually don't have to think about those sorts of errors. By the way, have you ever created a wheelchair? No? No? No, Perry. Yeah, it's good to have giant functions. They're good. Like having very small functions is kind of bad a lot of the time. Right, so we're going to get... So let's take a look around here. So readback. Have we got readback buffer cap? We haven't. Readback buffer capacity, we've got one of them now. Right, so the whole idea is we're allocating a slot in the, or a place in the readback buffer. And rather than recording an entry, actually, rather than recording an entry, I think we're just gonna literally like put it in the just put it in the command buffer. Right. So there's no need to care about the mapped memories just yet. We might need this later for the other one, but this one doesn't need it. And I think we're going to record... Readback target exceeds the bounds. Right. So readback cursor size advanced by size. I think that seems sensible. Right. So we need to call into the backend. So we need to make a new backend thing. Backend command readback buffer. we pass in the resource, we pass in the source offset, we pass in the offset into the buffer and the size. All right. Now we need a readback ID. You know, maybe we are meant to keep track of this stuff in some way. Because you get the readback ID, you get the size that comes back out on the data pointer. So we are going to actually have to keep track of this. So can I somehow on this? So I think in the internals, we need some way of tracking. So if I issue this frame, that's going to get sent to the GPU. Then I'm going to build the next frame. So while I'm building this next frame, the GPU is running the frame I sent. And then I send this frame that I've just built. And then with the next one that I'm building, I can now read back. While I'm building this next one, I can read back the ones that I from 2 frames ago, right? Because it would have completed. Because the GPU would have just started the ones I've just sent to it. So what do I need to do to achieve that? So ideally we want to store some form of like entry. And I think we need to triple buffer them because we'll be building this frame while we're reading back. Yeah, I think we need +1 of them. It's weird. Call it readback active frames. Say 1 built on the CPU or 1 is being ran on the GPU. And 1 is being read back by the CPU. So I think we need to make like obviously I want to like not have these hard-coded arrays, these 32s here. In the future we're going to correct that. But yeah, we need to do something like probably want to do something like that, right? So hey, good to welcome. How you doing? There was a discussion in Don's stream this morning. He made a wheelchair, and I wonder how many people have actually created such a thing. Wow. Yeah, yeah. If it's in OOP, would wheelchair be a subclass of vehicle? Good question. Good question. Or is it a subclass of chair? Or can it be both, right? Multiple inheritance. Or such send them. Every single expression, the expression. Oh no. Pure math, as the Americans call it. That's a lot of mins and maxes. Right. So, what are we trying to do here? So, we need to access the one that we're currently writing to this frame, and it probably changes every 3. So we need to find the active frames. You need on one of these. So we just need to like mod readback. Let's drop one of them there. Cool. Alright, so hopefully this is what we need. So go back to the super lovely readback. So I think what we need to do so this would be a number 0, 1, or 2, right? And we're going to use this 0, 1, or 2 number. And we're going to say, right, given the super lovely readback entries or whatever, can I... Yeah, sorry. Wait, which ones are we... These are we... We ideally need to triple buffer... Actually, we need a structure. Let's do it. Readback, buffer, something like that. I could just call it readback. I don't know. Right, so we want all of this, but not the cursor, right? Because you need one of those cursors. And we also need the mapped memories. All right, get all mapped memories. So what we need to do is say, right, GPU readback, buffer, readback, buffers, one of them please. And there we go. So I've got 3 of these guys. And the idea, so maps, memories, buffer entries, texture entries, something like that, yeah? So the idea will be that we say, hey, readback buffer dot buffer entries. Sorry, not dot buffers, index with readback active frame. So we could probably get the let's call it RB. Address of GGPU, readback buffer, buffers, readback buffer active index. So we've got that RB pointer. And what we want to do is get the latest entry. So that's RB index there. The new index is going to be, oh yeah, we're just appending it to it, isn't it? You know. So RB buffer entries like that. Anything upload buffer now is now host copy. Texture host copy, right. We'll sort that out in the future. That's the readback one. That's the upload one getting corrected. So this source offset is CPU offset. And then this one here is GPU. Excellent. So we jot down this thing for later, right? So when we issue this command, we jot it down, and then 2 frames later, we can effectively fish this one out, and then you can fish this entry out, and then we can actually like yeah, we can use it to read back the data, right? So CPU offset. So we'll write this function in a bit. It's just going to record into the command buffer to do the copy and everything. But I want to get the higher level stuff done first, right? Because this is what's going to decide how it works underneath. So this is good. I like it. We just need to allocate a readback ID. what is that going to be comprised of? What could be anything we like, but 0 has to be null. That's the way the ID stuff works in this code base. So what I want to do is I want to do two things. I want to store the index, right? What is the readback? What is the entry index? I want to store that in there. But I also want to store something else in here to help us capture any problems if someone uses this readback ID and either it's too late or if it is too... Wait, is that a good idea? Yeah, if it's too late or too early, so we can know whether or not it's ready or not, basically. I think that's a good idea. What should we do? Because if you have to read back and you have to wait for 2 frames, you're gonna have to keep hold of two IDs and paddle between them in the user code, right? And that's not really a good API. So ideally what a user would want is like, hey, I wanna ideally what I want as a user is maybe to have an ID that I register, and what I want is to register a bunch of readbacks to the same ID, and then I can iterate over all of them for that same ID. Maybe that's a good idea. If I were messing and C, just make an example C in GUI program work. Oh, okay. Yeah, I tried messing out for a bit. It was okay. I think I had a bit of a thing with it where I couldn't change some of the build settings without regenning messen or whatever. It's really weird. But yeah, it's okay. It's probably nicer to use in CMake, right? Right. I see. Good old SDFs. Okay, so is it better for an API where rather than us giving back something, you maybe say, hey, I want to make a new readback thing, and then anytime we read back, maybe we say, hey, readback create, and you just create some form of like handle, right? You didn't really care about it. And do we let you destroy it? Is this just say readback initialize or something? Maybe we need like a readback, do we call it? It's just called an ID. So we could say like, I think we'll think about it, but let's just get it adjusted. So I think we want to have something like, you pass in your ID or whatever here, whenever you do any of these. Okay. And what you get back is probably nothing. Something like that. And you're sort of registering this ID. And then we do this read back data, what you're saying is, on this frame, do I have anything? If you do, you get back up, right? So you say while read back ID. Yeah, I think we can do that. I think we can achieve that. That would be a good design. But I've just got to make that easily reflectable in this API here, right? So it's understandable. So you kind of want to have like a readback queue. I think that's a good name, right? Can I make my own readback queue? And you can have like a queue ID, I think. So you can make a new queue, and you can then pull off the queue. So it's just going to be something we increment, I reckon, just a number, right? So you can see like queue read, range read back one, get the size. Now we kind of want to have more information now that we can have multiple things, right? So maybe a nicer idea might be right, I think we'll put the structures above. Type def strut GPU readback entry, something like this. And the entry is going to have GPU resource ID. So what resource we're reading back? What is the pointer to the data that we're reading back? What is the size? What is the size of that data? That we're reading back. Anything else? Like, we could, you know, ideally pass all of this out. What is the information that came in about it? That's probably, that could be useful, right? You know, yeah, I don't think we need alignment. It's just not useful. Because we're just reading it back from the pointer. Yeah, because it could be useful when you read something back. You might be like, well, you just make your own queue for a particular buffer, maybe. And if you queue up multiple things for that frame, yeah, but you'll have your own, you know, it's not a callback, so you'll have your own context and you can just increment a number. And I think, yeah, I think that's doable. Like, this is a code base for me to make a game, and I think I can work with that, and it's not too confusing. I think that's good. So we ideally want to get this entry to come back out. So I have like an entry out basically. That will come out and return a Boolean. Ta-da! So that's the API that we want, right? So let's ensure that we can actually achieve this. So we're going to store. So instead now we want a queue to come out. And so right. So if we store this entry, so if you have like a queue, no, we have queue create. Exactly. So maybe, so these could probably be known when you sort of initialize the whole system. Maybe you don't need, yeah. You know, we could do a whole pool of these. We could do a pool of them. So let's just have a queue thing here. We'll have it as a structure. Readback queues. You know. Let's just say there's 32 of them for some reason. Let's also have like a number to say like, oh, this is the number you've got. And again, we'll probably make it a pool later anyway. Right, we haven't got some custom allocation thing in the code base yet. We're just trying to get an initial design for the GPU system, and then we can worry about the memory and that later on when it's all finished. So in here, we might have, so in this queue, ideally, we just want to know like, so all this readback buffers thing where it's just got it's triple buffered, and there's arrays of like these entries, and some of them are going to belong to different queues, right? And the way the API works is you read the queue, one queue at a time. So we could play it by simply iterating over all of the entries, and just basically keep a number in here to say, oh, you've got like 3 that belong to this queue in one of these arrays or whatever. That's one way it can work. Or you could keep a list of them actually in here, a list of pointers to them. And that's probably a slightly better way, because the pointers will probably be fixed anyway. They are different. That shouldn't be a problem. If you read back an image, you might need to zero fill. You just need to ensure you want to read non-para 2 texture. Is it? It's supposed to handle multiple readbacks into the same buffer, yeah. I'd love to become a graphics engineer, but without having to deal with Windows, is that even possible? Yeah, you can do graphics on Linux, but if you get a job in the industry, you'd have to know Windows. So I'm to think about these queues really, because the queue, it's interesting. Because if you open up a queue and you read like a buffer and a texture into the same queue, you could get the resource to tell the difference between them. Or I'm trying to see if yeah, so the queue is like a way for you to like assign multiple of the same kind of buffer, reads from the same buffer to the same sort of queue. And the behavior of reading it back will basically be the same across them all, I reckon. Well, first of all, you probably want to differentiate the difference between one-time readbacks and per-frame asynchronous readbacks. Yeah. So I've got that kind of. This one is like per frame, And this one will be like, you just issue it and it will do the copy for you. This one is like, you want to maybe handle the copy manually from the readback buffer, whereas this one is like, you just want to say, hey, read back this resource for me, and then you'll get back a true when it's copied, right? What is this? You making a game? Yeah, we're making a game when we've got the initial sort of architecture done. Right, between one-time readbacks and per frame asynchronous readbacks. The latter you can just throw into a ring buffer. Yeah, you can use a ring buffer. I'm just using a single buffer for now. I'm not bothering wrapping it just yet. But yeah, if you wrap it, potentially, that can be done in the future. So the key was to solve the problem of the fact the ID that was returned, I don't have the user to like paddle between two IDs. They could just put it onto this queue thing, and then essentially do a read from the queue. And maybe it's only one thing is read per frame from the queue if you're doing it constantly. That is okay. Yeah, that's fine. But is it useful to know the offset from where it came and the dimensions of it? Maybe that is useful, you know. So maybe you can like let's store a union in here, because I think this can be useful. Let's say, you know, there's a U64 offset for the buffer and size. No, because I don't think it'll hurt to pass it out, so let's just pass it out, you know. Well, I built from scratch. Any specific requirements in need? Pretty much new here. So I'm building a game specifically like sorry. So I've made this custom C compiler for shader programming, and the quickest way to test it out, and also the quickest way to avoid myself from like building an engine that's super general, is to build a game specifically, or is just to build a game basically, and not build an engine that covers many different types of games. So we're just building the core foundation of like the engine part of the game right now. So we're just getting the graphics up and running. We're doing compute only. We're not doing any traditional render pipeline. And we're just going to build up the essentials. Now, obviously, I'm doing readback stuff here, and you might be like, you don't need this yet. But these things are useful to have when you're simply prototyping. You might want to have a bit of a, like these tools around when you're prototyping. So I want to get these things in, so it'd just be easier to sort of like just get to using them rather than like not having them there. So there's only a few of these things, like, you know, I'm having, like I got printf, so we can print from shaders and display in the terminal. So it's going to be super handy when debugging. So we're building a few things like this. Intermediate rights. Yeah, I've got RenderDoc as well. We can use RenderDoc, that's for sure. But I'm like, these things just might be useful to have. Like, they're not too hard to implement as well. Right. So how are we gonna do this queue thing? Thank you, appreciate it. Um, yeah, so I think we're doing like 3D graphics as well, but we're gonna be starting off with 2D. We're gonna probably do some 2D UI soon. As soon as the graphics system is done and we've got all the GPU system is done, and we have like a custom memory allocation system and core collections and cleaned up the GPU code, then we'll be moving on to doing a basic UI system so we can like put up some debug UI, get some hot code reloading in. When we've got all those systems in, we can finally do some 3D and find an art style for this game. But yeah, that is the plan. It's hard not to overgeneralize when you do an engine dev. Always find myself doing more than I require. Yep, that is very true. It's very easy to like be like, oh, in the future I'll need this, in the future I'll need that. We are kind of doing that here, like especially with this readback thing right now. We are definitely doing that here, but I have an idea that I'm pretty sure this is going to be helpful while I dev, like or anything. It's going to help me maybe I can press a button and export a GIF. I can capture some frames, export, make a GIF, and then I kind of upload that to social media. So there are places where this can be used, and it'll be helpful just to have it here. Yeah, I know you render goblin. You're space goblin now. You're more the sci-fi goblin. How's things been, render goblin? All right. So we've got this queue thing. We can either just keep track of the number. Like you're probably not going to have a load of readbacks, right? So we could essentially just keep track of the number. Yeah, let's just do an array of them. See these host entries being separate from buffers and textures. Maybe let's just join these up. Let's just join them up because it's just causing problems. Resource, host copy, right? Let's just do some unions. Let's just, a nice bit of a refactor, but it'll be good, it'll be good. All right. So we can now get these texture ones. GPU offset dims GPU MIP. And there we go. So get rid of that trash. So this guy now, and now we can use this in multiple places. So I reckon what we can do is we can just have like, hey, here's all of the entries, right? The copy entries. And that'll be fine to translate over. Ta-da. Not bad. I've been like 2 month vacation playing games instead of making one. Nice. Yeah, it's good to play some games. I've been dabbling in some games as well recently. Nice and relaxing. And get to see what other people will make and spark those creative juices. I've been thinking about how to truly up the bar on my game. Oh, okay. Oh, I'm just using standard Vim tabs. Yeah, I just do tab new. That's all. It's just standard Vim. Standard Vim. Oh yeah. Just call them entries. All right. So what I reckon we can do is we can store an array of pointers to these entries, or we can just do a copy. I don't know. We could just do an array of pointers, like, so if you put them in there, we could also just do a copy, direct copy, stick it in there. Like it's just as a reference. Wait, maybe the entries don't need to be in there. They just need to be in the queue. Okay, okay. So with a queue, I think we're just going to be able to make queues. So I reckon what we can do is we can say, so the queue initialize is we are essentially just going to say GGPU, this queue count, this is going to be your queue index, right? And you're just going to say return for me a +1, something like that. We're not going to have a way to just like destroy queues because I don't think our game is going to need that. So okay. So when it comes to getting the queue, we are going to have an API for that. Readback. So I do want a way to get the to have a queue get or something, right? The ID, please. So I guess you should do the more internal things underneath. So this one's just gonna be really simple. You know, we could assert that it's not. You know, do a core debug assert non-zero. Maybe we should say like id.raw, I guess. Then just return. Probably do like an array bounds as well. What's the bounds? GGPU dot readback queues count. That'll do it. Then we can simply just say return the address of GGPU, readback queues, ID. So I probably wouldn't change that one other than change the allocations maybe. Make this a dynamic allocation, but I probably won't make it any more complicated than just an array of things. We'll see how that goes. So we can get a. So ideally, now we're going to get this queue back. Right, this is our readback queue, as we're going to call it. Fantastic. Pass in the queue ID. So the idea is oh no. Oh no, this is fine. Goes up there. Or maybe just have like the number of, or maybe the queue itself just goes into the buffer here. Perhaps. And maybe you have like a read. Like a read cursor or something like that. Um, So that means if you're gonna get the queue, you just need the sort of like, you want to get it for this frame, isn't it? Anyway, yeah, I think it could be okay. So this will be in readback buffers dot. We're indexed with GPU readback active frame index. Right, so that'll be 0, 1, 2, or, yeah, 0, 1, or 2. Get the queue from there. Excellent. So I think that will be good. So what we can do here is we can then append the entry to here, and this would be host resource host copy entries. Now this one's got to say buffer GPU offset buffer size, right? And you can be able to know based on the res ID which one it is. Then we call into the back end. I think that's good. Yep, that'll be decent. So then we can read back off the queues then. The only problem is when we start the frame, we're going to have to make sure we go over all of the queues in that readback buffer. So in the frame start, when the active, right, so we need to go over for all of the GPU dot queues count, right? We'll have to get the readback you get the readback buffer that you're currently on. So RB will call it address of GPU readback buffers GPU read active frame. Yep. So we'll just say RB queues index dot cursor equals 0, right? And you're also going to put the count. Wait. This one. So after you submit, before you reach the end, you want to set the cursors back to 0. So the next time this one is used, yep. Whereas this one is going to set the count back to 0. So when it starts building some of this frame, the count is set back to 0. Excellent. What is this Vim theme? It's a custom theme. I just made it because I like the theme Iceberg, and it's very simple. And it's blue, kind of a bluey one. It's really nice. I used to use this one, and I was like, I want something different, but I love the simplicity of this theme. It's just basically 2 colors. So I found 2 colors which are basically, you know, just slight variations of each other, and I just made a theme based on that. This is Don. Why not use Unity? Good question, Don. How's it going? Thank you. I can drop. Are you in the Discord? I'll drop it in the Discord later today after this stream, and I'll give you the way I've done it. No worries, no worries. Hey there, Nico. How's it going? How's it going? Okay, so we should. Right, let's correct. Oh boy. let's correct these guys quickly. Resource. This is the upload buffers. We'll just correct these and we'll get back to the readback. Buffer entries. Let's just sort that one out. Hey, why didn't that change? Oh, these are called entries. No. Upload. Entries. What are you doing? There we go. Right, so this is CPU offset now instead of source offset. Let's correct that. Then this one is GPU offset. So these would be specifically in the buffer dot. Oh no, this one's not buffer dot. Yep. Cool, that's corrected. This is upload texture. Texture entries needs to get deleted like that. Then a lot of these are GPU, and this is texture dot. Cool, then we want to just call this resource host entry. There we go. Right, so I've corrected the build errors for that one. And then we're back to this readback buffer. And so we've nearly finished this buffer one now and designed it. And then we can do the texture one, readback manual, and then we'll be able to do this lovely new read back from the queue. Right, that'll be super nice. It's gonna be amazing. Not using Unreal 5, exactly. Okay, see you soon, Renner Goblin. Ah, Notepad++, yeah. Don Ho, the creator of Notepad++. I can't believe someone has the same name as you and that person made Notepad++. That is funny. Like the chances of that, Don. They are the same people. Right, so we just need this backend thing, backend function. We'll do that in a bit. We've just been designing, again, we just want to finish designing this higher level part of it, and I think we have, but I just want to get the others implemented and then we'll go into the lower levels. So we'll leave that one there. So now we want to steal the upload one for the texture and simply duplicate it for the readback. Ta-da! So this is actually wrong. The API has changed. Now I've got this sort of QID thing that we use. Now the way it's got to work is we need the ability to get the queue, get the entry index. Wait, why did I need the entry index? Was that... Oh, I didn't use it for anything. That's kind of pointless. Anyway, we need these things to do that, something like that. So we're essentially just making sure it's all in bounds. The thing wants to read back. Then we don't really care about getting the pointer and using that. All we care about... Wait, did we increment the cursor? We did. Right, change this to readback. Readback. Readback target. Readback target. Rightio. Looking good. So let's just make the upload work sort of the same. Just put them back in the same sort of places. So I wanted to move that one probably about here. Grab these 2, 3. Right, that's pretty decent. All right. Excellent. Good, good, good. So now all we got to do is have this command that we record out into the... So we could just pass in the resource and the entry, right? And have a shared function just do a switch based on the type. That way it's not two functions. For the back end. Is it really two people or is it one person? Perhaps there's two developers on Notepad++. There's the other Donho and this Donho. We don't know. It'd be quite an awesome team. Two people with the same name making the same product. That would be awesome. So readback manual. Well, this one is gonna... Is this a good idea? Yeah, so readback manual is... You get a slot. So we still need an entry. Yeah. Yep. So you basically do whatever you want. We'll make an entry and we'll be like, hey, the offset is CPU offset and all this jazz. Then this is going to be core ID null, GPU resource ID, GPU offset, and the rest of it's just garbage data, right? Because the ID is null. So the idea is if this you want to read something back from the GPU, but it doesn't come from a buffer or a texture, instead it's computed information, and you want to compute it straight into the readback buffer, you can do that with this API. We'll just give you a source offset, and then from any compute shader, you can just write into that buffer, right? So that's another interesting way of doing it. Okay, so we kind of add to these queues and everything. Yeah, I guess I can make that safer later. Right, And this final one is actually reading back from... What the crap is going on? It's called cues, isn't it? Excellent. So the final one is actually read from a cue. So what we need to do is get the actual cue. Yeah, you get the current cue, and we say, right, if readback cue cursor is less than, okay, we'll just say if it's greater than or equal to the count, what we're going to do is return false. Now anything after here is true. And then what we're going to do is set the, we're going to increment the cursor by 1. And then we're going to say, right, entry out is equal. See, why is it a readback entry now? Like, we have that host. Ooh. So we have an internal structure called like host, copy host, whatever, right? It's this internal structure. But it's basically the same thing as this. Where's the dong? I think we still have a dong. Should I see? Does it work? Was that good? I got a new table. It's longer, it's wider, so the dong is probably going to be much deeper, you know, much more quiet. So we can either translate from this entry into a readback entry. Yeah, I think we'll just do that. It's a bit silly, but it will do. So what we need to do is we need to say, right, well, we also need to get the GPU resource readback buffer GPU readback active index, get that. Then technically this is just the address of queues, right? Ta-da. Then I'll queues whatever queue ID take 1 is. Did we take the 1 away? You know what, let's just use the function for that. We didn't take 1 away. Oops. Right. So anyway, so we're going to manually translate this over. So let's just get this sorted out. So the data pointer is going to be core pointer add. So just going to increment readback buffer mapped memories. Now is it mapped memories when it's just mapped memory? Because it's not an array of them, right? So mapped memory, please. So we need to make sure we actually get the mapped memory there in the Vulkan backend as well. When we do the backend side of things, so we've got to remember that. And then from the actual entry, so we need to get the entry. So it's basically whatever cursor is, right? So we need to get the readback queue cursor. And then from here on out, we're going to be saying entry and CPU offset, bam. The next one is the res ID. So that'd be entry GPU res ID. Yeah, some of these names are just a little bit silly. GPU underscore this, GPU underscore, it seems a bit silly to me. We'll correct those. Because they're all in texture anyway, you know? So, now the thing is, this is all like... We might have to do like an if statement here. Just to copy the data perfectly. copy it over better, you know. It's basically the same thing. Like, yeah, you know, I can't be bothered to translate. It just seems so silly. Why didn't I give you a pointer, right? Give you a pointer to back out. And then there's also a way to get the readback buffer data. Right, just get the data and you do the pointer offset yourself manually. It's not a good API though, is it? If you have to do the pointer offset yourself manually, it's a bit annoying. Maybe we'll store the data pointer in here as well, I think. So what it is, we'll make this so the problem is we have this public now. So I guess we'll just store a pointer in here as well to the actual CPU data. But like, the upload is not using it. Just the readback is using it here. I don't know. That's translation that way. So you can just return the pointer out, so you can just say, you know, dref entry out equal that. So that'd be like a double pointer, and this would be resource host entry. Yeah, that was really good out of context. So all this can go up the cursor, bam. Cool. Right. So we just need a way, like when we actually set those things up, we've got to set the data pointer as well. So we're quickly just going to, so the API is pretty much done now from the high level. We'll be doing the low level in just a second now. Just got to correct these namings of things. GPU underscore has to get sorted out. Now, you don't need to store data in here, like a data pointer in here. Like we could have the user fill in this structure, but yeah, it's a little less inconvenient. Okay. That's okay. So here we're going to say entry CPU data equal core pointer add from. Now we need to get that readback buffer. Readback buffer mapped memory CPU offset. Right, so you get your nice little pointer there. And I just want to take that and apply that to the texture one as well. Just plop that in there, get that in there. Remove this silly old GPU stuff, and voila. Manual is saying, right, so we need that CPU data as well in here. Yeah, so that'd be a really nice API to work with. We just do while queue_read, and we can just get an entry and look at that. I don't have to, as a user, have to paddle between two different IDs or anything. It's all, yeah, it'll work really well. So let's go ahead and implement the backend side of things. So we just need to open up source. So let's see if I can do this right. Backend .h, right? So I want this void GPU resource, and I want a GPU resource host entry. Copy host, a host copy entry, right? So simply, right, you use these command readbacks while you're building the command buffer, and essentially we're just going to issue a copy into the readback, into that allocated part in the buffer that you've made, and make sure we do all the transitioning stuff as well, right? It's not optimized in any way. It's just going to put the barriers in and do it. So you have to reorder your commands yourself if you want it to be more optimized. But yeah, so I think what we want to do is simply, so we need to do some barrier things, right? Yeah. So we'll be basically issuing, like if you do like 5 readbacks in a row, you're just going to have like pipeline barrier, copy, pipeline barrier, copy, pipeline barrier. So you'd have lots of pipeline barriers where you could possibly just have a single pipeline barrier. But yeah, again, it doesn't matter because it just does the job. And obviously in the future, if it's something we need to optimize, we can do that. Right, so let's get the pipeline barrier. So the one we're looking for is the one in frame start. This one already does the work we're looking for in a way. Maybe we should correct this first, because at the end of the day, this is going to be using the same stuff now, actually. So we'll get this ready. So instead, these are actually just an array of entries now, right? And it's this resource host copy entry, right? There's no DST, it's just a res ID now. Get your sync state, and off you go. So what we need to do is we need to say, hey, if resource type equals GPU resource type buffer, then you do this thing. Whereas if it's not a buffer, it's obviously a texture of some kind. And then what we can do is use this one down below and then delete all of that, right? So that's what's been nice about combining these structures, I guess, is we get to share this sort of code. So then it does this pipeline barrier thing. So it does a synchronization code. So we just need, so we do this where we say right before we copy the uploaded data, we place a barrier to transition everything to be ready for the fact it's about to be copied, right? It comes from being written to by the by a compute shader, and then it transitions into being copied. So after that, we perform the actual copies, right? So again, I've got to do this thing instead, and do this if statement again, where we say, hey, if it's a buffer copy, go to DST crap. So be a CPU offset, buffer.offset, buffer.size. And then if it's not a buffer, it is a texture or image as Vulkan calls it. Then we're just going to do this copy. So basically these copy functions that we're seeing are the exact ones we're going to be doing when we use it in the... well, no, not the exact ones. We'll use the other way around. We'll be saying image to buffer. But yeah, it'd be very, very similar sort of code. CPU and DST is now texture dot. Okay. No need for the extra for loop anymore. Just a if statement now instead. And then one more final thing is we need to transition them back into saying, hey, we can use those in the actual compute shaders again. And you do this upload. And again, we need the if statement. But what's great is we can copy these three things and change them. If statement. And then if statement. Okay. So that can all go, and then we do the pipeline barrier, transition it back into being ready for this compute shaders to use it. Okay, right. So now we've got to do this thing again, but specifically for readback, right? Oh, also, wait. Before we do that, we create our readback buffer. Where is that? We do a map. So this one is specific. We ain't done it yet, have we? No, we've only done it for the hprintf stuff. So we haven't actually got a readback buffer yet. We kind of need one of those. Can I take a look at the... What about the Vulkan internal, please? So if we look at the internal global stuff, we do not have one for... What do we want? What are you saying, Don? So I think so we need 3 of these, right? And not 2. Because one's being built by the CPU, the other one's being written to by the GPU, and the other one's being read from. And I don't know, that feels wrong. So maybe the data needs 3. We need 3 sets of data, metadata, but the buffers themselves, you only need 2. Right? You only need 2 because one's like when one is being built, it's not necessarily. Yeah. Yep. It's just the metadata, you need 3 metadatas. So when we make these hprintf buffers, yeah, maybe it would have been easier to like make a function for this to make it easier. I don't know, but whatever. So I'll call that readback buffer now. Boom, readback. So we're just gonna, create the buffer, allocate it some memory, all that stuff, right? Readback buffer, readback. Okay. So what about the memories, right? So the memories need to go into... Oh my days. Hmm. So there's actually 3 of these. Oh my days, the queues and this readback buffer thing. Right, so there's 2 actual buffers. And there's 3 metadata. There's... readback buffer capacities. So I think... the queues just need to be separate. So... yeah, the queues need to be separate. These you need... any active frame count of those. So it's only for the metadata, isn't it? Yep. See, unless you read them back in a very small window, maybe the first thing you do in the frame is deal with your readbacks before you do anything else. And then you don't need that extra one. So the API could be just very strict. Right, you do your readback queues right after frame start, and then as soon as something has been recorded, you can't read back anymore. Like you could just say readback begin. So maybe we can undo that. And then what you can do is you can delete this one here. And there's only needs to be 2 now. And then I think you can remove this thing here, right? And just have 1 active frame thing, which make it a lot easier to reason about. But it just restricts the user API, meaning they can't do it for the duration of frame begin to frame submit. They have to do it within a region, probably before frame begin, frame start, I reckon. Maybe we can say readback begin, or readback start, readback finish, right? Start, readback, end, and you have to do everything from within here to do with this queue, right? And I think that will have to happen before frame start or something like that. Frame submit, I think that'd be good. Oh no, it has to happen right after frame start, because when you do frame start, it waits to make sure the GPU is not writing to those resources. That's correct. Yep. Okay, I think we've got this. Right. So that'll be decent. So it means we can write to buffers index dot map to memory. Bam. So we map the memory, copy the map to memory to there. Excellent. Rightio. So let's go back up to the GPU.c and finish, implement these two things, get the logic there correct. Oh, we buggered this up now, haven't we? Not to worry. So read back, active frame, whatever, has to be nuked. Okay. And at the start and end, the idea is, so probably need another Boolean. So we'll like a bit and say has frame started, right? So you kind of want to know, like, has some command been recorded, right? Has command been recorded? Like this frame. And also has readback. Has been. You can actually read that as read back as well, can't you? Has read back, but English. Yeah, it's English for you. What's the better name? Okay, has read back happened. So what we need to do is we need to make sure we set these. We can do a frame start. These two guys here, GPU. These guys are probably going to be like set to false, right? Then as soon as you do a command, not necessarily a sync resource, but a dispatch, you're gonna just set it to true, right? Yeah, command's been recorded. Also, if you do one of those readback commands, right? Yeah, command has been recorded. Yes, the command has been recorded. This one, a command technically hasn't been recorded, but I don't want you to be able to do a readback thing. So here we want to do an assertion. So if the frame hasn't started, right, readback start must come. Oh, wait, that was a copy and paste error. Right, I'm glad we've redesigned that because we found this problem. There we go. Right, readback start must come after frame start and before the first command, before the first, like that. Let's just say it must come after, right? And then we do another one, and then you want to say like has command been recorded, so we want that to be not true. Start must come before the first GPU command start. Okay. Then if we are then we want to set GPU dot has this happened equal to true. Bearing in mind, we also want to make sure that this is also false, and must only be called once per frame. Okay, so then when you end, you've probably got to set something else, right? Yeah, this is in a very weird state. Like, we could just have a state enum, and the state enum will probably be better at describing what's actually happening. And you're just transitioning between the states, right? So, you know, maybe be better if you have like your, maybe like a type def UA GPU frame state, something like that, and maybe just say, hey, GPU frame state, maybe like you could call it record state, right? Maybe like record state, not recording. The other one would be started recording. Okay, or not started, started. Then there's recorded. Oh, we have recorded at least one command, right? Maybe that should be a better name. And the other one will be finished. But there might be another state where you are reading back. You're processing the read back, right? So record state is a bit of a weird name, but yeah, maybe it's okay. Yep, that's true. Naming is difficult. But with enough time and different concepts coming together, you can usually come up with some good names. But yeah, record state just seems like super general. Like, it's kind of like command buffer recording. Right, but it's like a frame that you're building. Right, so I could call it GPU build state. Right, you're building a frame. Frame build state. Alright. Frame build state. So, frame build state, not started, right? We're reading back. We are recording, or we have like, maybe we want to say like, it could also be a bit set. Or is a bit set a good idea though? Or do you want more of an enum? Because we kind of have a bit set with these booleans. Right, so obviously making a bit set is basically having the booleans anyway. So I could just fix it by just adding another boolean. Yeah, let's just add another boolean. This is not, yeah. Has read back, started, finished. Right, there's all those together to see if it's happened or not. So started, I guess ended. Okay. Then effectively here, make sure it's not started and not ended. Yep, once per frame, cool. And then it started here, and you must be able to call, make sure it has started and not ended. And must be called after, like, after readback end. So there's two, right? Started and not ended. Must be called once per frame. Then you want to set this one here to true. So now what we need to do is make sure that the commands don't, that anytime we have one of the commands, we want to make sure that started equals ended, right? GPU readback start or end must be called before recording a GPU command, right? So this is going to have to go anytime there is a GPU command. So you kind of want to just throw one here. See, ideally it's like you want to probably just have a function, probably on the internals or whatever, where you just say like command begin or command assert, right? So I don't know where I'm going to stick it. I'm going to stick it down here. So I want to have like a command assert, just be void, right? And I think I want to just like, I want to throw that thing in there that we had, which I've lost now. Sync. I want this thing here. And then I also want to set that GPU has command been recorded, so that's true. Whereas every time we've got one of those, we're now going to drop this in its place. We can always just extend it, right? So that'd be super nice. And we want to stick that in command sync, drop it in there. Bam. Awesome. Awesome. So what is going on here? Ooh, did we forget to clear some of these? Trace cursor and count. Nope, that's fine. All good. All right. Okay, so at the start of the frame. Ooh. That's interesting. Like, even if you don't do the readbacks. So maybe we want to say like, hey, if the command hasn't been recorded, but it's about to be, can we set up the readback for this frame? And can we make the entries count 0? Probably set the is it? Frame submit, wasn't it? Yeah, clear the cursors down to 0. Each one in the queue. I'll do fun. Cool. I think that's good enough now. So now we can finish implementing the Vulkan side of things. So let's go to the Vulkans. So we're looking for, right, this is it. This is our thing. So we need to go and grab that copy host, or host copy. Okay. So this is for the upload buffer. What I want to do is grab all of this, and we simply want to just implement it for, they do the other way around, right? So every single time we call this readback, so right before we copy the data into the readback buffer, place a barrier for the readback buffer and the source buffer or texture, right? So what we're going to do is have ultimately 2 possible barriers or 1 image barrier, right? 2 possible buffer barriers and 1 image buffer barrier. And so we first of all add the readback buffer, and this one is going to take it from being, is it host rate? I think it's going to be, see, we haven't done the transition code in the other place either for it. But yeah, it will currently be in the place where it can be used for compute shaders, and then it will be sort of like in a probably more of a general shader storage rights bit, and the destination is going to be like, hey, it's going to be copied from a copy to with a transfer right. Okay, then the buffer is the readback buffers. Then we'll get this active frame thing, cache that in a little local variable, stick it right up here. Bear in mind, yep. So this is good. We're saying, yeah, let's do the whole size, it'll be fine, I think. All right, now we go over all of the entries, but we don't need to go over all the entries. We just need to do it for the specific entry. So we've got the entry pointer that comes into the function, and what we want to do is get its resource, get the backend thing for it, and get the sync state. And if it's a buffer, we're going to be doing this stuff. And remember, this is our thing that we are reading from. So it goes from being whatever it was before, or whatever state it was in before, we transition into being read from, copied, and then we'll add it to this buffer, or it'll just be an image one, right? Hey, Colima, how you doing? Yeah, they're doing good. The wife is doing good. Yeah, we had to go to the hospital, unfortunately. Kind of like halfway through last stream, but yeah, she's doing good. She had trouble sort of breathing, like, well, like she could breathe right, but it was like quite hard to lay down and breathe. So she's yeah, went to A&E, sat there for like 3 hours in a chair, and eventually saw someone and got some drugs. Thank you, thank you. But yeah, it's all going well. Baby's all healthy. Should be coming in around a month and 10 days. That's its due date. So probably around that time, I'll probably take a little break off streaming, just to sort of see how things, how things, because it's my first child. I don't know this. Like I don't know what it's gonna be. So I'll probably take like a week off, maybe a little bit more. I'll see, and just figure out this baby. Get some things that I've probably missed, and make sure everything is going good. But yeah, thank you for the wishes. Appreciate it. So this is our source buffer or texture. Right, we're just going to transition it. So we don't need to get the resource because we've already got it. Bam. Now we do our super lovely such a yeah, we definitely want to like have something that we increment here. All right. Image barrier. Fantastic. So we fire off that super lovely barrier. And now we go and perform the actual copy. Man, Vulkan. What are we going to do with you? So the copy is slightly different. So the copy requires, like, this one is probably fine, right? Oh, no, it's the other way around, isn't it? So the source, the source of the copy is going to be the buffer, because it's a buffer one, right? And we're copying it into the readback buffer at that size. Then, Now there's two buffers here. I think they've got to go the other way around. Ah, you bugger. Yes, I think that goes the other way around. User include the Vulkans. Very cool, underrated territories. Sorry, uncharted territories as dad. But I'm sure you do. Will do good. Thank you so much. Yeah, I just gotta, be open-minded and think, when I was that age, how did I feel? And how did I feel when my parents did this or did that? And just try and sort of, articulate to the child well, but also, not like let him get away with everything, So try and draw a good line. It's gonna be interesting. And also, yeah, lots of asking people advice as well. I've been doing quite a lot of that. Source image. Ooh, copy buffer. Source, then destination. Radio. Source. Oh, I call it DST. Like a silly person. Right, it's not the upload buffer anymore. It's the readback buffer. So, now, this one here is not buffer to image, right? It's image to buffer because it's going the other way, right? Interesting. So if it's image to buffer, no. Image to buffer. We just got to work it the other way now. So image to buffer copy. Right, source image first. Then the layout. Then this readback buffer thing. Then the region. So it's a buffer image copy. The offset will go in there. That's fine. Yeah, I don't think any of that changes. That seems legit. Very good. Rightio. So the final thing to do is do another one of these barriers to transition it back. Vulkan is so much fluff. Look at this fluff. Fluff everywhere. So the idea now is to go back the other way. So we transition the readback. So now we have copied the readback data, place the pipeline barrier for the readback buffer and the source buffer or texture. And we essentially just want to have a maximum of 2. One of those, and we need those there and there. Okay. So here's our readback buffer. It's going from being written to being used in a compute shader. And then we put in our readback buffer there like so. Ta-da. Then we go over not all of these entries because guess what? We've only got one entry, right? It's not the most optimized way of doing it, but it will work well enough for our application here. So image barrier dot. Now the source is going to be read from. Oh, did I change all of those? I need to double check above. Into being back into the mode it was before we started doing this readback, right? Source optimal. I gotta go and make sure we get that right. Let's go back up. Transfer source optimal, please. This one needs to be a read as well. Damn it, these if statements and different things. Okay. This has a boolean whether or not it's a texture, is that right? Oh, a sneaky. False. Things were slightly incorrect then. Right, readback command, fantastic. So this readback command is now done. So this will be complete, or this would be complete, but except for, no, we're missing one thing. So we can now record commands, readback commands, and do the copy. Right, that's great and everything. But we haven't got our readback buffer transitioned into the correct state when we start that frame or when we finish the frame. So we just need to go to frame start and find where we do it for the upload buffer and just add a thing in here. So basically this here does one for the hprintf buffer where it transitions it from being host readable into being written to by a compute shader, and we basically want to do this again. Because remember the hprintf buffer, as we saw with this lovely thing here, it prints, this is all printf coming from shader code, and it effectively works by having the shader atomically write out to a buffer that we then read back from on the CPU. So it is basically what we're doing, right? So we need a read back. So we need a read back to be transitioned from being host readable to then being written to by a compute shader. Then we need to do that same thing again at frame at submit. Right, it's right there. We need to say, hey, now that we've reached the end of our frame, what we're going to do is we're going to say, let's transition our readback buffer in from being a like written to by a compute shader to now being read from by the host. Okay. We're missing an invalidate as well. This is interesting. Yep. So we need to invalidate the caches. Can we do that? So we flush the caches, and we do this in frame start. But what we really need to do is we need to be like, right, where is it? Where's the size of this readback buffer? Cursor, isn't it? This is not good. So I think the cursor needs to actually belong to... Let's think about this. So the cursor... No. So when you start a frame or start a readback, you need to invalidate the caches from the CPU side. So you need to know the range, the buffer range. So you could cheat and just do the whole buffer, but it'd be better optimized if you just do the region that you've actually copied from. Sorry, copied to, right. So how you know that is, so yeah, you can probably double buffer it. You can definitely double buffer it. Buffer cursor, let's call it cursor, right? So I reckon we can do that. That'll be pretty sweet. So I reckon what we can do, we need to invalidate the caches. So when you do a frame, is it a frame end? It's not a frame end, is it? So like, when you do a frame start, you've waited. When you do a frame start, you've waited for the semaphore, meaning the CPU now has access to the resources it needs to build the next frame. So for instance, it will get the upload buffer, it gets the command buffer, also gets the readback buffer it's going to be reading back from. We can guarantee those resources are not being written to by the GPU. So what this means we can do is we can then invalidate the caches for the readback buffer. So we actually need to do this for the hprintf stuff as well. So oh yeah. So we need to do that here as well. So invalidate Perfect. No. Okay. So when you invalidate the memory ranges, what you need is we need this frame's readback buffers GPU. Wait. Active frame index. Perfect. Dot cursor. Right, that's what we need. Bear in mind, before I forget, I need to make sure that at frame start. No, we already do this, don't we? Oh, we didn't do it. Yeah, we need to make sure we do that. We need to say GGPU readback buffers active frame index dot cursor equals 0. Restart that right there. Yes, and not at readback start. That's not good to do it there. Do it here. Okay, anyway, back to the... So it needs to be aligned to this non-coherent atom size, right? And this would be the... We'll call this the readback buffer size. If it goes bigger than the readback buffer capacity, we'll just do the whole size of the buffer, because that's valid for the spec. Hey there, Lean Mean Gene, how you doing? What does the game look like? We're currently working on the GPU backend right now, just getting the core parts of things together so we can actually prototype quickly. So we're just getting a nice simple API that has a good set of like features that we can use, but not go too overboard, right? Just features that'll be useful while prototyping and stuff like this. Yeah. They are really great in terms of the level of control you get. Like in terms of the capabilities you can do, like in comparison to like OpenGL, there's so much more like capable things you can do. Like to the point where, I've written my own C compiler, and shader programming is pretty cool nowadays. It could be cooler, but it's pretty good in comparison to what it has been. But in terms of to achieve something, it is a lot of silliness, right? Yeah. We've had to copy and paste so much code. We're at about 2,200 lines now, purely just because I've copied these massive pipeline barrier structures, which basically don't do a lot. They basically just say, wait here until this thing is done. They take up like more than 2 screens of code. But yeah. So readback buffer size, okay? Device memories. Okay. So invalidating the caches there. Oh yeah. So this means, right, the CPU, if it's got some cached like okay, this readback buffer could be in RAM, right? Main memory on the computer that you're using. And you could have in your L1, L2, or L3 cache, you could have this readback buffer in there. But the GPU wrote to main memory, and the CPU didn't know about it. So what you're doing here is you're instructing Vulkan to say, hey, invalidate the cache, the L1 and L2 and L3 cache that has this buffer in it. basically, and that's all it's going to do. And the flush caches does it the other way around. It does it for the GPU instead of the CPU. Right. That's all it does. You just have to make sure you do that. So I actually missed doing it for the upload for the hprintf side of things, which is not good, but it's fine for this hardware because it just works, right? But ideally, like, because they had the cache coherent bit or whatever. Yeah, possibly because it had the coherent bit, but we need to make sure that we're fine. So what we actually need to do is have an array of these guys, and you want to do it for the hprintf side of things as well. So hprintf. Now, I don't know, like, you have the maps memories, right? What about the interesting enough is we don't actually know. Right, it's controlled by the GPU. And we don't actually know, so we just got to do the whole buffer. So it makes it easier for us. So we just say, right, I think we will be doing this again, right? Remember, because we're doing another readback buffer in a second. But so this will be, hey, I want to read back from the hprintf. We'll do the hprintf one first, actually. hprintf buffer device memories, and I want to do GPU hprintf buffer cap. So we'll just do the, wait a minute, whole size. That's what we meant to do. Needs to be an array. Core array count for memory ranges. Okay, so that's going to validate it for the readback buffers. Ta-da! So that right there, when we get it compiling, should be readback buffer completely implemented. We should really test it out, but I don't know. Yeah, we can test it out. It shouldn't be too difficult to test out. We'll just write it out from a shader. Sure. Software rasterizers will be way faster, but to write. But when you get up and running, it won't be nowhere near as fast as a GPU. The GPU is crazy quick at doing graphics. So, right. So this cursor. Damn it! I need this readback buffer thing. Oh, right. Let's copy this over here. I thought I copied these so they were in the same order. There we go. Right, let's corrected that. Let's compile. Readback manual. Sort that one out. Getting pretty close, just one more. So this didn't set the out. And it's not source out, it's destination out. So destination offset out is going to be, why does it need to come out via a, technically it could be a You know, I'm just going to leave it as an out pointer. It's not the best design, but it keeps it the same as the upload. So, consistency. Right. So yeah, it's compiling. So we could go and test this out now. Right. So first of all, do we break it? Well, we didn't break it, so that is good. So what I want to do is like, can we make a buffer? We're gonna write to it. We're gonna write to it. Copy it back to the CPU. Read it back. So we ain't done this one yet. We have time to do that. So we want to be able to, yeah, this would be a really good thing to test. So we're just going to test copying a buffer out. We don't care about the texture one because that'll probably just work. Because it's pretty much the same code. It's just differences by calling into Vulkan. And I guess there's some assertions in that. But there are things we can just fix when we just want to use it, and it wouldn't be too much of a big deal to fix because at like an architectural level, they'll be the same. So all I want to test is simply, so I need to make a key. So let's get there in the graphics side of things. And what I want to do is, so we don't really have a buffer that we write to, so we could just test manual. Manual means it'll be doing the. Yeah, we don't really have a. Do we have a buffer? Oh wait. We could just read back the logo texture. And then do like a byte to byte. Should we try that? Yeah, okay, we'll read back the logo texture. And then we'll do a byte to byte comparison to see if it actually. Yeah, that's all we'll do. Hey, on Tanner? Yeah, doing good, man. Yeah, everything's still going via compute. We're just working on readback buffers right now. We've just thrown it together, so we're just figuring out a test subject. I don't know if you saw last stream, but we got printf working, so we can now print variables from the shaders into the terminal. So that was our first type of readback buffer. We're just trying to think of a test. So I think I want to read back this logo that we've got from the GPU and do a byte to byte comparison to make sure the readback buffer works, you know? I think that'd be pretty cool. So let's do a couple of static variables. But how's things going with you? Image data, right? We'll do another one. Well, we're gonna say like we want to have that GPU readback queue, isn't it? Right. QID. Okay. So what I want to do is say QID equal GPU readback Q initialize. So step one, make a queue. Step two. Nice. Find us really tired of late. Oh no. Are you working those long hours still, or is it just or is it more of a drinking too much caffeine type of thing? I'll take these off. It's getting a bit snug in here. Might open up the window just a little bit more. Oh. Nah, that got better Oh yeah. But just got lots of things on my personal plate. Weighing me down a bit. Fair play. Well, I hope those things get a. Hope you find a solution soon, and yeah, get a way to wind down and take a break. Um. So we basically wanted to stick the image data in a global, and the width and height we can just hard code by the 256. So that's cool. So what I want to do is simply issue. So remember the way the API is going to work is we're going to say readback start, and you start your readbacks, and then you end. Okay, so it's just some nice API like this, and it has to be called before you record any command, and then this means that, yeah. So this means we don't have to triple buffer anything; it can still be double buffered, and yeah, so what we need to do is we issue our readbacks via a command. So I think what I want to do is say readback texture. What I'm going to do is readback. So to do that, I need a queue. So the queue goes in there. Then I also need, see, I forget this already. So I need a queue, I need a resource. So the resource is ggfx.logo texture. So reading back the logo. We are going to read back an offset from 0, 0. So times 3s 0. And then we're going to read back a size. So the size is 256, 256, 1. And then the MIP is 1 and the array layer, well, sorry, 0, 0. Yeah, you read a MIP 0 and array layer 0. Cool. Because they don't have any of those, right? So, nice. So we're going to send this up. 2 frames later, it comes back here. So we're going to say if GPU read back Q read. Okay, so this is where the fun begins. Man, I think I'm pretty glad how this API turned out. So you can get back this entry pointer, and yeah. So get back, and it's like an iterator. So you say while we have stuff to read for this particular queue. So you can have different queues for different resources. You can put them all down one queue if you want, doesn't matter. It's just a way of associating some group of resources to one type of queue, so the logic could be different. It's nothing complicated. And then what we can do is we can get the CPU data. So I want to do a memcompare, core assert, memcompare entry CPU data with image data, and it will be 256 times 256 times 4 because it's 4 bytes per channel. Sorry, 4 bytes per pixel, right? Because there's 4 channels, 1 byte each. Then make sure that's equal to 0. And the quick assertion is going to be, image data does not match, right? Ta-da! So let's just run that every frame it's going to check, and let's see how that goes. So I do want to maybe print out and just say check. And then I do want to disable the printf code. So we're going to hop into the back end, and where it does the hprintf stuff, does it somewhere. It's in the invalidate, isn't it? Oh, is it outside? Yeah, yeah, it's here. Okay, we'll comment that out. We just got hit by a large shower, so it's cooling off. Awesome. Yeah, it has been a bit warm here a few days, although it did storm 2 days ago, briefly, and apparently it's going to rain a bit on Friday. But yeah, at least the grass isn't completely dying. I did try and water it, but that didn't go too well. Right, so we're getting some problems. Good. So I'm glad we're testing it. We can fix these. So in the read, 0 of 0, because when we probably allocated the queue, we didn't increment this count here, you see? By the way, enabling proficiency is almost on par on previous editor. Loving it so far. Awesome. Yeah, it's really... Ooh. It's getting stuck, isn't it? Yes. Vulkan errors. But yeah, like it's really awesome when you get to that level, because now it's all just uphill from here, you know? Just gotta put in the time to sort of like still catch yourself, and you can just keep going up and up. What editor was you using before? Was it VS Code, or was you doing like Sublime, or was it a full-on IDE? So this is failing because it's saying it used to be in source optimal. Wait, is that right? Old layout on the Vulkan spec states if this blah 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 is in this, or the old and new layout define image transition. Or the image must be created with source transfer optimal. Wait, source transfer usage. Aha. So we're just going to say, hey, anything can be... Yeah, because right now we've got an image usage. So we're just going to say, hey, anything can be read, like copied to or copied from. Yeah, we're just going to do that for every image, you see, that we make with our... And any GPU only texture or GPU only buffer, because that's what our buffers and textures are, unless they're a special one like upload or readback. But yeah, we typically just make them GPU only. So we're just going to make sure either one of these two that we make with our buffer initialize or texture initialize are just capable to be read back or read from or written to. Right? Next. Image to buffer copy is saying buffer should have transfer destination. Uh-huh. So that's the readback buffer when it's created. When is it created? That is here. Transfer destination. That should be the same for... Oh. Printf. This is never transferred to. You only write to it from a shader. Interesting. So we get rid of that. Nice one. Next error. So now the previous layouts differ. So this is in the image to buffer copy. So this one's saying it's meant to be in destination, but it's meant to be in source, right? Because you're copying from the image to the readback buffer. So that's the problem with that one. Correct there. And there we go. So it's checking it. It's going check, 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 check. And the assertion is fine. So if I were to remove... See, I can't remove the readback, But what I can do is offset this thing. I can offset it by a pixel, right? And if I offset it by a pixel, the the memory will be, if I offset it by a pixel, it won't be a direct comparison, meaning this will fail, right? So that's the way we can test it's true. There's an assertion. Shoot. 1111. Oh, 110. Let's try that. There you go. So the check failed. It displayed for one frame, crashed the next frame because we need to try to read it back, right? So there you go. So I managed to check that now. That's super sweet. I'm just gonna sort out this blind situation. It's getting dark. Yeah, every day I feel like the ceiling of NeoVim just gets a little higher. Always something new to learn. Yeah. VS Code 10x4 coder, but VS Code worked fastest for you. Okay. When I started learning Vulkan a week or two ago, the whole experience is like, this is crazy. Yep. Yeah, it's ridiculous. Like, as I was saying just not too long ago, the capabilities it gives you is really great, but what you have to do to achieve that is ridiculous. Like, there's just so much stuff you have to do. But this is why we're trying to do very simple using compute only. And we're just getting all the features we need together now. But yeah, there's some really crazy stuff you have to do if you want to write a really optimized Vulkan renderer. Like if you can do your sync code like perfectly, it's crazy. Yeah, just getting through device installation or initialization and triangle setup is alone is a lot of hassle. Yep. Yeah, and then as soon as you do that, you've written a really great triangle renderer, but good luck doing multiple triangles or anything like that. It just gets crazy. Not long ago, tried NeoVim with TJ setup. Yep. Couldn't figure out how to configure the LSP for a single translation unit build. Back to Emacs. Oh yeah. Because the LSP just complains about everything, doesn't it? Yeah, typically though, I just like to include them proper. Like include the header files in each C file anyway, and that gets around it, right? Oh, yours is nice. Okay, so this is super awesome. We've got this readback working. Now, we kind of want to do this other way of doing readback, right? What happens if you don't want to do this, right? What happens if you don't want to do this? And, because doing this is a lot of effort, and it's very frame, it's critical to like putting it in this exact spot, and you can't simply check in some area of the code base where you might be like, is it done yet? And then when it's done, awesome, I can just go and do my thing, right? So what we kind of want to do instead is we want to have this way of saying readback buffer copy, and we're just going to copy it. Like it may be one-off, right? It may be you might do it continuously, but it might be one-off. And you're simply just saying copy it into this pointer for me, please. and then let me query the status of that. Will I need this API? So it'll go through the queue system still, but you have an extra thing to say, essentially, I want to copy this texture. I want to copy this out to this destination pointer, right? So yeah, I'm not sure if I already need it, because this first one, the reason why I put this one in is because if I want to write like a simple, if I want to press a button and we can record a GIF or something and I can upload that to social media, this API is going to be perfect for that, you know? Whereas this copy one, it's like if you're giving, yeah, maybe it is fine, but you've got to like, yeah, maybe it's got to be, maybe it's going to be like, I'm dispatching a compute task, and then when it's done, I want that data to come back to me on the CPU, but I want it to be in a more persistent pointer, more persistent rate, more persistent place in memory, right, where it doesn't just get overwritten by the GPU again. And so I can then maybe for the gameplay, I can then do something, right? Maybe we fire up maybe we do some procedural generation on the GPU because it's faster for some reason, and you can then copy it, right? To more persistent space. So yeah, I think this can be useful. So to achieve that, so what I might do now is commit this code, because we probably won't finish this next one today. And let's undo this. Wait, where is it? Yep, that's it. Let's just get that working. There we go. So it's doing the check. So we're just going to say git status git. I think we like all that. Pretty sure. So we've added this readback thing today. Yeah. Git commit, sort of like add readback buffer. Something like that. Q. So I need to do this silly thing here. Let's push to the origin. Wait, no, I need to do my that's it. I do not know why it does not work for GitLab. It works for GitHub, but when I did my GitLab thing, it just doesn't work. So I have to keep doing this silly dance. I have no idea. Right, so just push that up. Then I want to do a git tag for day 8. Then git push tags. Wait, origin tags. Yeah, it's still struggling. All right. So for those of you who want to get access to the code, there's instructions here on the Discord. How to get access to the code if you fancy. Right, I need to post up my theme later on to my Discord actually. Yeah. Right. So how are we gonna do this? So effectively, it's built on top of it. So we just need to say we need to inside this readback buffer thing. We need we need to maybe have. Is it part of a queue? It's not part of a. Like, we could have a built-in queue. Right, why don't we just have a built-in queue? And the built-in queue can do the reading itself and put it out into the. Yeah. Isn't that amazing? So why don't we just do this? Right, why don't we just say, hey, can we have a can we have a where's the internals at? We want to have a built-in See, is copy a good name? We could call it auto copy. Right. So if you call it auto copy, So we'll call it like. So we get the auto copy queue and readback queue like so. This is simply just going to return index of 0. Right. So when we start off our GPU initialize, we're simply going to set ggpu dot readback queues, start that off as 1, right? You know, index 0 is the auto copy queue. So this means when we do any of these, we'll add them to the auto copy queue and simply we've got to find a place where we can stick the destination capacities and all of that. We'll think about that. Auto copy status, and we have an auto copy ID. Cool. So I want to get all of that. I want to go to the implementation of that queue read. I want to then put this down here. So the idea so I think we're going to have an array of in that readback data. Can we close that and get back? So I want to in this readback queue it's not per queue, it's more like So you want to have your auto copy entry, and you probably have an auto copy entry per so you're just going to store the destination. You don't really need a destination size. You just need a destination pointer, I guess. So these would be the auto copy entries. And let's just say there's 32 of them. And let's also just say you've got auto copy entry count or something like that, right? Anyway, so what we're gonna do is we're gonna allocate from that. Well, yeah. So I reckon what we're gonna do. See, maybe these things should return booleans to say whether or not they've actually done anything. Because if the size is 0, it wouldn't have actually done anything. So maybe it's good to see. See, if the size is 0, do nothing. Like, it's a bit silly to assert, isn't it? But I think returning a boolean is always handy, because it's basically free, right? So we can always return a boolean here. Bool, return false, and then return true at the bottom. False there. If size equals 0, yep. So, hey. Oh yeah. So then that means when we call those functions in here, it will be easy to do the auto copy thing or not, right? So we can literally just call, we can say, right, if not of this result ends up being, so what is the key? Well, we have the, where's that internal function? This could just be a constant. Define GPU readback. So that'll just be core ID. Oh no, not really. GPU readback. With a 1 in there. Cool. That's the auto copy ID. So we've got that one. Chuck that in there. Then we're going to say res fantastic. That's going to return some null ID. Right. So if you get a null ID back, so if you try to do a copy, you get a null ID. What does that even mean when it comes to status? You probably would just want to say the copy is done, right? Because, yeah. Cool. So now here's where you actually want to store that auxiliary information. And we kind of want to make sure we do some assertions where we say, right, you got this destination capacity. we just want to say, okay, chorus cap must be greater than or equal to size, and then we're just going to say, you know, so it's more of there as a safety measure. The destination capacity cannot fit the size. ZU cannot fit the size. ZU. What is this I'm meant to be seeing, Marriott? I can't see it on my phone. What is this? It probably showed up, you know, okay on your screen, but yeah. But it's quite interesting. Got some tiles. Cool. Right. So what we need to do now is actually allocate that new slot in this thing here. So we need one of these guys. Let's get that. We then want to allocate a new entry. So it's RB for readback buffer. RB auto copy entries count. Increment this by 1. Obviously, we should do something better than this in the future. Make it safe, but it'll do for now. Give the entry. Now in the entry, what we want to do is simply just put the DST in there. Now, when we're doing the auto copying, it's a queue. Yeah. This is good. Then, okay. So what is the ID going to be? How's this going to be architected? So what we need to do, because there's some status thing, we need a way to store, we need a way to be like, has this thing been copied yet? Well, it also needs to store an index to the copied item. Is that right? We could probably just do it with a fence, you know? All right. Yeah, I don't know. Like, ideally, because the problem is, in frame submit, what happens is we increment the frame index. And this is the thing we're going to be figuring out how if it's done or not. But it gets done when frame start is called, it's going to get done. Because after this is when it's safe to read back and do it. So we're actually going to do it in here. And then so ideally we just need like some form of frame number that we can reach. Yeah. I think we might call it, I don't know if I want to call it a fence or not. But yeah, you know, maybe we're just going to store the frame in that. Yeah, this is what we're going to do. We're just going to say dot raw equal GPU dot frame index plus 1. Now this can overflow. So because it can overflow and technically land on 0 when you do that, like we just want to be able to take a difference, right? So we'll probably just ignore the first bit. So I think what we'll do is we'll, but then we can't ignore the first bit then. So maybe an ID is not the correct thing. Maybe we'll say, we'll give you a frame number back. Right, that's all. We're just going to give you a frame number back. So we'll probably make a custom type for it. So it's more self-documenting. And what I want to do is store that somewhere up there. And we'll give you back a frame index. See, we could make it, we could have like an invalid frame index. But we did 0. No, so we'll probably give you back the same frame index, I think, something like that. So we'll probably just say, you know, let's give you ggpu dot frame index. We'll just give you the current frame, right? If it fails, then this one is going to give you frame index plus 2. Then I think that's pretty decent. What do you think I should order off of DoorDash? Interesting, type beaver. I always like a good Indian, you know? I like a really spicy curry, that's me. You into your curries? It's always good when you get someone from who really knows how to cook a good curry to do it, you know? Banana knee. What? Where do you live in like the middle of nowhere? How do you have no Indians? Damn. Bunch of chicken and okay. What about a Mexican? You have a Mexican? They're also good. Love me a good Mexican, you know? Get a burrito packed with rice. Gotta get those Mexican beans in there. Taco Bell, do it. Do it. So what we're trying to say is, so we'll cast them to an S32, right? Take the difference, right? So we'll go towards the current frame from that frame. And what we're trying to say here is that if that is, it's got to be greater than or equal to 2, right? But if it's equal to 2, then like frame start must have been called. And in order to know frame start has been called, there's a boolean. Ta-da! So what you want to know, you want to basically do like, it's a bit. So you want to say like 1 plus that, right? Because if it's been, wait a minute, or is it minus? So you want to have the difference must be. So it's got to be 2 or greater if it hasn't, it's got to be 3, right? So you're doing the not of that. right? Plus the not of that. Because if it's 2 and it hasn't started, if the difference is 2 frames and you've not done frame start, then the copy hasn't happened, right? The copy hasn't happened. But if the frame has started and the difference is 2, wait a minute. Yeah, this is wrong. No. If it started, then it'll be 0, so it's adding 0. Yeah, this is right. Good. So we just want to say, like, you know, readbacks take 2 frames to sort of like be auto-copied, but only after GPU frame start has been called. But on the second frame after, but on the frame 2 frames after, very poor way of saying it. Readbacks take 2 frames to be auto-copied, but get copied in the call to. Okay, that'll be good enough. So now we just want to get this one in here. So in the texture one, it's basically the same thing, but we just do for texture. So the size though, we're going to calculate that size. Let's just do this texture one. Offset, dims, MIP, array layer. So to calculate the size, good question. It's just multiplying, isn't it? So much of a brain. No, yeah, times the bytes per pixel. That's right. Oh crap, we're not calling that command thing, are we? Let's get that in there. Cool. Wrangle the resource. Alright. Hey there, Ansel, how you doing? Good to see you. How's things been? Bytes per pixel size. I think that's good. So the final one is a manual autocopy. So it's the same as this one here, basically. Yes. Manual, no resource, but just a size. Right? No? Oh, and a source offset to come back out. Excellent. Right, I think that's about it. So we've just got to write one more function, and that's actually perform the auto copy. Right, so we need a way to do this queue read. So effectively, we need to call this queue read. Oh, we haven't got this assertion in here, have we? Should we get that in there? So what we need is a way to say, we need this. must be called before GPU readback end. Must be called after GPU readback start. Before that. Yes, excellent. So we kind of want to call this function, but without the... You know what, we can call it. So what we want to do is at frame start. It's going to be a bit of a hack, but it's okay. So we just want to do this, right? We want to say, right, readback has started. And then we'll set it to false again. Shoot. So we set it to true, so it avoids the assertion. And then we're going to say while we have stuff queued up. I want to use that super lovely readback queue auto copy ID. And then I want to get back the host entry suite. And then we're simply just going to do the copy, right? So remember this structure here has the place, the readback buffer pointer. So we should just be able to say literally, wait a minute, we need to get the U32 auto copy cursor, start that off at 0, incremented by 1 every iteration, and then we want to get that auto copy entry. One of these, no. Yeah, one of these auto copy entries. So we get the current readback buffer. We want the auto copy entry, which is going to be based on auto copy cursor. And then you simply want to say memcopy for me, please, directly into the destination pointer that the user specified. And then I want to say copy from entry CPU data. And then the amount we're copying is, oh shoot. Well, this is a good way to test out the API. What is the size we're copying? There's no size in here? I don't know what happened there. Not when you're doing uploads, right? I'm not fussed about that, per se. You know what, maybe it should be size. I've got to change it in a few places, that's fine. This is readback, right? Yep. Which means we need the size set as well in the texture one. It's all in there now, very nice. And we also need it for the manual as well. Sweet. So you probably want to stick that above because it's U64. Nice. So we've got to correct that in the Vulkan backend as well. Now I made that change. But let's just finish up this, right? So what we're doing now is we actually have the size we can copy. And that should be it, right? That should be all we need to get an auto copy from the readback and see when it's ready. Hey there, Suspect Zero, how you doing? If I miss any, wait a minute. Time to go and get one of the last trains and bus home for today. If I miss any of them, it's faster to walk home than wait for the morning trains, right? How far's the walk? So we've got to hop into the Vulkan side of things. Let's correct some errors. Very nice, it should be good. Alright, so press F5 now. Apparently it all compiles. Does it still... Oh, get out of the bashes. Ah. Right, so it still runs fine. And it's doing the read back and copying back fine. Obviously, we didn't really change much of that code. It was just renames of things. But we want to try out this new auto copy API, right? So it's super nice now because now we have an auto copy. So what I want to try is, can we maybe say, hey, auto copy, right? Can we get this to work? So I want to say static int init equals 0, right? If not, init equal 1, right? So it's just going to call that once, and we're just going to call this once where we say auto copy, and I just want to say yes, the destination pointer. So I want to say this equals malloc, right? Not a fan of malloc. We've got better ways to allocate memory, but we're just going to do it for now this way because it's quick and easy. 256 times 256 times 4. So there's the image that we're reading back. I want to throw it into this place. The size of it is this amount, and then we're reading back logo texture, this offset, this size, and this array layer and MIP. Then what we're also doing is, right, so that gets us back some form of like handle, right? It gets back a frame static GPU frame index, right? So the frame index, we want to say, right, if GPU readback status, I forgot it. Auto copy status. Maybe it's not really a status, maybe it's something like complete, but we can always change the name. Let's see if it works. Doing good, homie. Making the game from scratch. Yeah. Awesome. Yeah, we're doing it completely from scratch because I want to test out my custom compiler for shaders, but also I want to, because I've spent a lot of time faffing around making a generalized engine and, you know, through trying to learn these things and everything. But I think it'll just be a lot. I've heard people say, you know, if you just write exactly what you need for a game, it's much easier thing to do, and you can write specialized code for that game and really tailor the code base to that problem. So I'm trying out this idea, and I'm writing my own code base around that. And then in future, hopefully, I should be able to copy these code bases around and change them completely to suit the needs of the project, right? You know, you can gut things, you can implement new areas, right? And just it's really flexible in that regard. But you do have to, like, you know, design stuff from scratch sometimes. But yeah, I'm just trying out the idea because I've always built general engines before, and I want to see how this one plays out. Yeah, I've been doing an engine as well. I'm thinking making an engine is good for learning, and making code just for a game is good for actually producing something. Yeah, because it's very easy to like just keep trying to solve in a very general way. Yeah, and really just really also overcomplicate things. So yeah, I'm also trying to document it as well as much as possible. Well, not document it where it makes sense. I'll do like a devlog or something and talk about things. So I think the next devlog I want to do is when I've got the initial GPU finished, right? And just talk about it. We've got we can create buffers, and we can upload things or read back. Talk about the APIs and that, and just those people who are interested in that specific thing. But as times go, it might be a little bit more high level and towards like game features as opposed to low level things. Depends. But yeah, so what's the readback status? We're passing the frame index, I guess. So I guess call it like an auto copy. Right, so what we're trying to say is like it's copied, awesome. So now I want to just simply do the mem compare check to make sure it's just, make sure the data is good. And that's all I want to do. So we also want to print out to say, hey, let's put a core breakpoint in here and see if it does a trap or a whatever it's called first. Right, so we hit the trap. So the trap will mean, breakpoint has been hit, and it can open up a debugger and have some fun. But now we know this function is actually being called, so we're going to remove that. And now check if the mem compare makes sense, actually happens. Got to recompile it. And there we go. So apparently the auto copy is working and the readback is working. So standard readback is working if you want to do it the long way, where you do the copy yourself manually. Sorry, not the long way, the more fixed way. It's got to be done in a certain region. Whereas this one here with the copy allows you to just get it to automatically be put into some persistent place in memory, and whenever you like, you can just check to see when that's done, and then it's forever there until you free your own memory, right? So that's super awesome. Let's get that committed. Git status quickly, git commit -a. So add readback auto copy support, I guess. So I want to go back into bash again. I want to do that eval thing. And then what I want to do is sort out the tags. So first of all, let's do a push. Then what I want to do, now let's push those up. I want to delete day 8 tag. And then I want to tag git tag day 8 here. Don't be a silly. -d in it. Okay. Then we do a day 8. So we git log that. We'll see that now now it's moved from here to up to here, day 8. Right, now I just need to push the day 8 tag back up. So people who are looking at the code base can go to that day and have a play. So push origin dash dash tags. So that pushes the tags up. Yeah, on a roll. So that's really cool. We've got readback buffers in today. So what is left to do on this GPU API? There's not much. We're actually nearly finished before we need to do some custom memory allocation stuff, then come back into the code base and do a cleanup of the GPU side of things. And, you know, get rid of these super silly, like, arrays that have just got 32 entries and got this count thing sitting next to them. You know, make these much better. But that's not just yet. We've still got one more readback buffer I want to do, because again, it will just be useful when we're debugging things, or maybe not. The thing that I want is a readback command buffer. I don't know whether it's called a command buffer or not, but yeah, maybe we'll call it a readback command buffer. Basically, like the CPU can send GPU commands, right? Via doing command buffer recording. So you record dispatch, you record a copy, you record this and that. We want the ability for the GPU, with all of its massive threads and everything, to be like, I want to send the CPU commands, right? It's got to be, so the logic to do things on the CPU is controlled by the GPU in one or two cases, imagine. So we already have this in the code base, and that is printing, right? We're sending an array of print commands. That's it. But I want another one specifically for other things. So it could be for debugging. It could be actually used for something. Like you might be generating or have some state that persists on the GPU, and we sort of maybe, I don't know, it could be anything. So it seems like a thing we can chuck in, and it can be useful. We just need to get that ready. Yeah, so I need to add that one more readback buffer. So readback command buffer, and something that we can basically process. There is also in the shaders, we need a way. We currently have these resources here. Yeah, we need an easy way to access these resources inside the shader without having to pass it up via one of these constants. We don't want to pass in a print buffer every time we want to do printing, right? I want to have some constant that we can refer to those specific built-in buffers, right? So we can do printing from any shader very easily, but also so you do the readback or upload buffer. But notice how they do get double buffered. There's actually two of them, and they get swaps, the double buffered. So maybe we join them into a single one, and then just swap them out behind the scenes anyway. Yeah, I think we might do that. Yeah, I don't think that's too hard. Yeah, I think so I think we'll fix this problem and do the other readback buffer in the next stream. And then after that stream, we're doing custom memory allocation and making a stack, making a object pool, maybe a hash table. Get those things in because they'll be useful. And then we can come back to the GPU, really clean it up, finish that thing off, because the code has got some to-dos because of the new, we need these We need a way to create arrays properly in object pools and things like this. But once they're in, we can change the code and clean it up. And then we can actually start using this GPU API, which would be cool. And doing some rendering. All right. So, yeah. Let's just post some links here. There's a Twitter that I post on sometimes. Yeah, so we start not quite soon. Probably not till about day 12. No, maybe longer, maybe 15, because we need to make a simple UI. Yeah, we need to make a simple UI. So there's YouTube, Discord, there's a VOD channel where these go up on if you want to catch past streams as well. They're all up on there. Discord if you want to hang around and see me. I typically post more like, what's happening in the streams or like, other programming bits going there. What else? But yeah, feel free to. Yeah, so the next stream is on Thursday, 6:30 p.m. GMT +1, and I'm gonna have to skip Sunday's stream because I've got a family thing going on. Yeah. As they say, making your own UI is the first step to madness. Is it? I've made my own before. It's not hard. The problem with UI systems is people overcomplicate them, right? This is how simple a UI system is, right? Okay. when Milton wants to load. All right, here we go. So, what's the problem? It's 2D graphics. It's just a box, right? And it's a box that you subdivide into other boxes. This is UI. Do not overcomplicate the problem. If you overcomplicate this problem, it's insane. Like, yeah. They're just boxes. That is UI. Like, people use like whole big UI frameworks which do some really insane stuff. Yeah. Like I think like text rendering is quite complicated nowadays, especially in the whole UTF-8 thing. That's complicated. But again, we don't have to do that. Right. Warload fonts, free type. We'll probably just do a bitmap font just to start off with, and it will look kind of rubbish, but it will do. Or I might do a free type font, only load the ASCII in. Maybe, yeah, but then you got different sizes to deal with. Or I could do a sign distance field font and just do a big one, only do the ASCII table, and then use a sign distance field font. So, I don't know. Font rendering is just pretty crap. It's always a crap thing to deal with. But yeah. I've had some ideas around doing alternative ways of doing it, but it's a whole endeavor that I want to avoid right now. Because, yeah, I just want to write the game, right? So, no more endeavors. Silly endeavors. Right, let's find somebody to raid. Right, let's see what is Kanji still doing that thing where he's just looking at his. I don't know why he does this. He's like streaming, talking, just talking. You can't see what he's doing, and he's got like 4 screens. I don't know why you would just stream the computer screen and what you're programming. I don't understand. You've lost your ways, Kanji. On large font tables, would you segment up textures for ASCII charts or use other segments for higher values? On large font tables, And then other segments for high values. Yeah, you. Mm. Yeah, you could separate the texture and yeah, just put the ASCII all on one side and then do something else. Hmm. But yeah, I want to try and do the most simplest thing for font right now because it generally doesn't matter. It just has to display text-looking characters. You know what I mean? But ASCII is unfortunately different between OSs. What are you talking about? No, it's not. There's an ASCII table, right? Man me some ASCII. That's the ASCII table. It's not different across OSs. It's a American standard code. Yeah, there you go. American standardized code for information interchange, right? 7 bits.